This whole unit is going to be centered around circles. So today and tomorrow we're going to work on some circle basics, starting with the fact that all circles are similar. So all regular polygons are similar. Circles fit into that category as well because I could either stretch or shrink any circle to make it match another one. So we're going to start with that. Here, this just shows you kind of how we can show that. First, you would look at your two circles, and what we're going to do first is map one onto the other by translation. So you would shift it over by aligning your centers. So this center A we would put on top of center B. And then lastly, using transformations, we can dilate one of our circles to match the other one. So in this case, we're stretching the small one to meet the big one. So we're putting the big radius over the small radius. But that's not always the case. Sometimes we shrink the big one. So you just got to pay attention to the order of things when we do this. So we're going to do a couple of examples. Right here it says determine the translation vector and scale factor of the dilation for the following similarity transformations. So what we're going to do, it wants us to map A onto B. Our final result is circle B. So I'm going to connect the center of circle A to circle B. And if I was going to translate this, I would have to go down 1, 2, 3, 4, 5, 6, 7, 8. So my y coordinate is going down 8. And my x coordinate is going right 1, 2, 3, 4. So that'd be a positive 4. 4 to the right, down 8. Okay. Then from here, if I put this circle actually down there, so this is a radius of 3. So down here, if I extend this to be a radius of 3, and I draw a circle. Let's see here. Got to shift this down just slightly. Here's my circle with a radius of 3. I need that radius of 3 to actually be a radius of 4. This one, the whole length is 4. Okay, so to make my circle A into circle B, I would have 4/3. Because I'm making it bigger, the bigger number goes on top. If I was shrinking it, if I was making it smaller, then my smaller number would go on top. Okay, so try to think about that when you do these. But I would first move it here, and then I would multiply it by 4/3 to make circle B. This one is the opposite. We're starting with circle B, because that's on the left, and we want to end up with circle A. So pay attention to which direction you're going. But here I'm going from B to A. So that would be going down 1, 2, 3, 4. So my y coordinate's changing by going down 4 and right 1. Okay, so that's my vector. And I'm going to go ahead and move this circle. So it has a radius of 3. So if I make a radius of 3, those would be a couple of my endpoints. Try again. There we go. And if this is a radius of 3, the whole radius, I'll go this direction this time. So there's 1, 2, 3, 4, 5, 6, 7. Okay, and I am trying to make my circle bigger. So I would do the bigger number on top. So 7/3. Okay, so there's how we do that. And that's how we show they're similar. Using some of the transformations we used earlier in the year. So again, circle basics. We have to start with these definitions. So a circle is, and then we're just going to define parts of a circle. So the center is the exact middle. So right here, if I label this, this would be the center. So we're going to say it's the middle of a circle. Okay, circumference is 2 pi r, which is the distance around the outside of the circle. Okay, and then I'm going to go ahead and add also that that is 2 pi r, or pi times diameter. A radius, these are terms you probably already know. A radius extends from the center to an edge. So distance from the center of a circle to the outside edge. Okay? A chord, could be and probably is a new vocabulary term for you, but a chord just connects two endpoints. It does not have to go through the center of the circle. Okay, so when we define that, let's say distance across the circle that is not through the center. And diameter is another one you probably already know. Would be the distance across the circle through the center. Okay, so make sure you have these. We're going to move on and do some more definitions on a new circle. So a tangent line. Let's go ahead and draw it first. It is a line that extends off a point on the outside of your circle. So these were line segments because they stop. Tangent lines and secant lines go on forever. They're not segments. So here, a tangent line would be, let's go ahead and label that T just to make it clear, is a line that extends from a point on the outside of a circle. Okay, a secant line is similar, except it's going to go through 2 points. Okay, so if I make a line here, it's like a chord, but it extends on the outside. So for our definition, we'll say a line that extends from 2 points of a circle. Okay, it's similar to a chord, okay, from above. But the chord is just a segment. A secant line actually extends. We should probably add that it's not through the center, which is why it's similar to a chord. Okay, we'll do these last 4 on this last circle. But an arc is just a section of the circumference. We've already been finding arc length actually in our last section, so just a piece of the circumference. So let's say actually, I'm going to go ahead and make an example here. This could be an arc length because it's just a piece, or the outside could be an arc length. So the major arc would actually be this outside piece. Section with an angle larger than 180 degrees. Okay, and then the minor arc is just the opposite. So this would be your minor arc. Is the section with an angle smaller than 180. And then a semicircle is half of a circle, or half circle. We are still working on circle basics today. So we're going to match these terms with the pieces of the circle to start with. And I think it's easier to start over here and then match them with what they go with. So AC is this piece, that's the radius. So that goes with A. DEF is an arc, and it has to go in that order. So DEF, let me highlight what I'm talking about here for you, would be this arc, which is a major arc. Okay, we're going to focus more on arcs next week, but major arcs are labeled with 3 letters. CB is just this, well, it's talking about this line, which is a tangent line. Then we have point A, that's the center of our circle. DCE would be this arc, which is a semicircle, that's half a circle. Point G is an exterior point, it's on the outside. DE is a diameter. A chord, or here, CD, the arc length CD would be a minor arc. CD would be a chord. Secant line, and DF, that works, okay? And remember, the difference between a secant line and a chord is just that the secant line continues, so it has the arrows on the end. Okay, number 2. Circles A and D have radii of 4 centimeters and 1 centimeter respectively. Use this information to determine the missing values. So 4 centimeters for the larger circle, 1 centimeter for the smaller circle. And it asks us to find BF. B to F would be a diameter of 8 centimeters. AD would be 5. CD, so this one will actually have to use the Pythagorean theorem. This would also be 4 because it's a radius. This whole length is 5, and we're trying to find a leg of this right triangle. So I would do 5 squared minus 4 squared is 9, and the square root of 9 would give us 3. So CD, the whole length, so not just this piece, but the whole length is 3 centimeters, which makes CG, if this is a 1 because of the radius, just CG would be 2 centimeters. The perimeter of this triangle would be 3 plus 4 plus 5, which is 12 centimeters. Draw the following relationships. And there's no one way to draw these. It's really just, can you draw one of them? There's not going to be one correct answer. But a secant line, remember, goes through 2 points. So we'll make 2 points, A and B. With a line going through them. So that's a secant line. Intersects M. I think this means this was supposed to be circle. Circle M of points A and B. So circle M means that the center is M, and there's our secant line. Secant line MN intersects tangent line TM on circle R. So circle R, let's make a secant line first, MN. Again, this could have been any 2 points on your circle. And then tangent line TM. So tangent line only goes through 1 point, so we'll make it go through M because that's what they have in common. And then I need to put a T on here somewhere. Okay, diameter AB. So we'll start with a diameter. AB. Intersects tangent line GB. So I need to make a line tangent to B. And then somewhere on here, I need a G. This is GB and circle M. Okay, so that's what my examples look like. If you were to draw these on your own, they would be similar, but they wouldn't necessarily be in the exact same spot.